Swayam Prabha. Digital India. Educated India.
Hi everyone, welcome to the lecture number 7, which is the third lecture on labor supply. If you recall the last lecture, we discussed on decisions of hours of work taken by the individual with the help of the utility function and the budget constraint. In that situation, the optimal consumption of goods and the leisure for the worker is given by the point where the budget line is tangent to the indifference curve. So, based on that, the worker decides that how much hours of work he should work and how much leisure he should enjoy. We also discussed what are the factors that can bring changes to the decision of hours of work, like when the non-labor income changes, when the wage rate changes, how this decision of hours of work changes of the individual. In this lecture, we will discuss about the labor supply curve. We will derive the labor supply curve of an individual as well as for the economy at aggregate. Further, we will discuss about the elasticity of labor supply, how to measure it, and what are the issues in the measurement. Now, let us go back to this graph which we discussed in our last lecture, that we have taken the non-labor income here, say 100, the endowment point of the individual is E, and the individual is having so many utility functions. Considering the wage rate $10 per hour, the optimal point is achieved at point P, where he chooses to consume $500 of goods and services, and he chooses to have 70 hours of leisure and 40 hours of work. So, we had already discussed that why the worker will choose point P when comparing with point A, comparing point with Y. So, it is the tangent point of both this budget line and the indifference curve decides that at that point the consumer, the worker maximize his utility of consuming both goods as well as leisure. Now, from this graph, if we could draw the relationship between hours of work and the wage rate, then we can derive the labor supply curve of an individual. So, the predicted relationship between hours of work and the wage rate is called the labor supply curve. How a person's labor supply curve can be derived from this utility maximization problem. Let us try to understand that and derive the labor supply curve of an individual from this utility maximization problem. Now, if you look at this graph, on the x-axis we have taken hours of leisure, on the y-axis we have taken the consumption, and the total hours of leisure which is available for the worker for a week is 110. Now, the worker is having some non-labor income, therefore, his endowment point is here at point E, which means if the worker is not entering into the labor market, if the worker is not working or not supplying any labor hour, then he is going to have the utility at the point E and he will operate on the utility function which is U. Now, at this endowment point, the worker is having the reservation wage. The reservation wage is nothing but the absolute slope of this utility function u. Let us say this absolute slope of this utility function at this point E is $10, which means the reservation wage of the worker is $10 per hour. So, the worker will enter into the labor market, the worker will supply its labor hour if the market wage rate is greater than this $10. So, this is the reservation wage. So, now the worker is at point E, where he is having the utility which is U, and he is having 110 hours of leisure. Now, let us say the market wage rate is 13, which means this is going to increase the opportunity set of the worker. Now, the worker is having the opportunity set which is this line. Now, operating on this line, the worker is finding his utility maximized with the utility function with this line, and the tangent point is at point, let us say A, and corresponding to that, the worker is going to work for 20 hours and the worker is going to have the leisure of 90 hours. Now, if the wage rate increases from 13 to 20, definitely the opportunity set is going to increase. So, now the opportunity set for the worker is this line, and the worker is going to have the maximization at point B, where he is going to have 70 hours of leisure and 40 hours of work. Further, if the wage rate increase from 20 to 25, you can see that further the opportunity set of the worker increased. Now, with the worker is having maximizing his optimal combination of these goods as well as leisure at this point C. Corresponding to this point C, you can see the leisure hour, he is going to have 80 hours of leisure and or 30 hours of work. So, what we can see here is that as the wage rate increases over and above this reservation wage, the work hour increases. When the wage rate was 13, the worker decides to work for 20 hours. When the wage rate was 20, the worker decides to work for 40 hours. When the wage rate is 25, the worker decides to work for 30 hours. Now, you can see this is the wage rate and this is the hours of work. So, now point here is that if we can draw the relationship between these hours of work and the wage rate, we can derive the labor supply of this particular individual worker. Let us do that. Now, corresponding to this figure, on this side we have tried to draw the relationship between hours of work and the wage rate. So, on this x axis we have taken hours of work, on the y axis we have taken the wage rate. If we could derive the relationship from this maximization problem, now we can derive the relationship between these hours of work and the wage rate. So, as the wage rate increases from 10 to 13, the work hour increases from 0 to 20. When it increases to 13 to 20, the work hour increases from 20 to 40, and when the work hour increases, when the wage rate increases from 20 to 25, the work hour now is 30. Now, let us draw this relationship. So, when the wage rate was 10, means the worker is having the reservation wage which is 10, he is not going to work, he is not going to supply his labor hour. So, his work hour is 0, he is going to consume all 110 hours as leisure. So, as the wage rate increases, now you can see when the wage is 13, the worker is ready to supply 20 hours of work. When the wage rate is 20, the worker is ready to supply 40 hours of work. When the wage rate is 25, the worker is ready to supply 30 hours of work. Now, you can see the curve is positive slope up to a point, when the wage increases. After that, the slope becomes negative. So, the figure implies that the substitution effect dominates at the lower wage rate and the income effects dominates at the higher wage rate. Further, this figure talks about that the labor supply curve, the relationship between the optimal number of hours of work and the wage rate. Initially, the labor supply curve is positively sloped as the hours and the wages move together. Once the wage rises above this 20, the income effect dominates and the hours of work declines as the wage rises, which creates a segment of labor supply curve that has a negative slope. So, the type of labor supply shown in this figure is called the backward bending labor supply curve, because eventually it bends around and has a negative slope. So, we can use this utility maximization framework to derive the labor supply curve of every person in the economy. Further, the labor supply curve is the aggregate labor market is given by adding up these hours that all the persons in the economy are willing to work at a given wage rate. So, if we add all the individuals in the economy, how they are deciding their labor supply with respect to the wage rate, then we can get the market labor supply curve. Now, here you can see for worker A, WA is the reservation wage and his hours of work, supply of labor is labor supply curve is this. For worker B, the reservation wage is WB and this is his labor supply curve. So, if we add these two individuals labor supply curve horizontally, we can get this market labor supply curve. Now, WA, this is the reservation wage for worker A and this is the labor supply curve for worker A, and the reservation wage for worker B is WB. This is the labor supply curve for worker B. We just add this these two individuals labor supply curve, we can get the market supply curve. So, below this WA, no one is going to work. If the wage rate is above this, then the worker A is going to decide to enter into the labor market. If the reservation wage is above WB, then worker B decides to enter into the labor market. So, this is how you can derive the market labor supply curve of the workers. Now, let us try to understand the labor supply elasticity. Elasticity means how one variable responds to the change in the other variable. Here, we are trying to find the relationship between hours of work and the wage rate. So, how hours of work is responsive towards the change in the wage rate, that is the labor supply elasticity. So, we can measure this elasticity of labor supply simply by percentage change in the hours of work divided by the percentage change in the wage rate. So, the labor supply elasticity gives the percentage change in the hours of work associated with 1% change in the wage rate. We can estimate it simply by delta H by H divided by delta W by W, which means percentage change in the hours of work by percentage change in the wage rate. Now, the sign of this labor supply elasticity, it depends on whether the labor supply curve is upward sloping or it is downward sloping. However, the labor supply elasticity is positive when the substitution effect dominates and it is negative when the income effect dominates. Further, if hours of work are more responsive to changes in the wage, the greater will be the absolute value for this labor supply elasticity. Let me give you an example. Suppose that the worker's wage is initially $10 per hour and she works 1900 hours per year. As the wage raises to $20 per hour, she decides to work for 2090 hours per year. So, we can estimate the elasticity for this particular worker as his wages increase from 10 to 20 and his hours of work increase from 1900 hours to 2090 hours per year. So, we can simply estimate the percentage change in the hours of work, means it is from 1900 to 2090, which is 10%, the percentage change in the hours of work. And when we look at the percentage change in the wage rate, which is from 10 to 20, it is the 100%. So, percentage change in the hours of work, which is 10%, and the percentage change in the wage rate is 100%. Now, if you want to estimate the elasticity value comes out to be 10 by 100, which is 0.1. Now, question here is that we got the elasticity value, which is 0.1. How to interpret this result? How to interpret this value of the elasticity? So, when the labor supply elasticity is less than 1 in absolute value, the supply curve is said to be inelastic, which means there is a relatively little change in the hours of work for a given change in the wage rate. If the labor supply elasticity is greater than 1 in absolute value, it indicates that hours of work are largely affected by the changes in the wage rate and the labor supply curve said to be elastic in nature. So, many studies have been conducted to examine the empirical relationship between hours of work and the wages. Let us discuss on the empirical findings on this issue of labor supply elasticity. While doing a review on this literature of labor supply elasticity, we have focused on the labor supply of men particularly and estimated the labor supply elasticity of men in the labor force. Since most prime age men participate in the labor force, the typical study uses the sample of working men to correlate a particular person's hours of work with his wage rate and his non-labor income. So, our objective is to correlate a particular person's hours of work with his wage rate and non-labor income. We want to estimate the labor supply elasticity. So, we can write an equation which is Hi equals to beta Wi plus gamma Vi plus other variables, where we are measuring this Hi is the number of hours that person I works, Wi gives his wage rate and Vi gives his non-labor income. Now, from this equation, we can estimate the labor supply elasticity. In this equation, the coefficient beta measures the impact of a $1 wage increase on hours of work, holding the non-labor income constant, and the gamma coefficient measures the impact of a $1 increase in non-labor income, holding the wage constant. So, going back to this neoclassical model of labor leisure choice, which implies that the sign of the coefficient beta, which is the labor supply elasticity, depends on whether income or substitution effect dominate. So, beta is negative if income effect dominate and beta is positive if substitution effect dominate. Further, assuming leisure is a normal good, this neoclassical theory also predicts that the coefficient gamma should be negative because workers with more non-labor income to consume more leisure. So, in empirical studies, there are many estimates of this labor supply elasticity. As a result, we find a large number of variation in the coefficients in the estimates of the labor supply elasticity. There is a large number of variation. Some studies report the elasticity to be 0, while other studies they report it to be very large and negative. Still, some others report it to be large and positive. Further, there have been some attempts to determine which estimates are more credible. Some of the surveys in US economy conduct and concluded that the elasticity of male labor supply is roughly around minus 0.1. So, how we interpret this minus 0.1 labor supply elasticity for male in the economy? It means a 10% increase in the wage leads on an average to 1% decrease in hours of work for men. So, a 10% increase in the wage leads to 1% decrease in the hours of work. That is the aggregate effect. If we would like to decompose this effect, then the decomposition into income and substitution effect, there is some consensus that a 10% increase in the wage increases hours of work by 1% because of the substitution effect, but also leads to a 2% decrease because of the income effect. So, the net effect we are having a negative. So, there are three key points to discuss on this labor supply elasticity value, which is minus 0.1, which is a consensus estimate of the labor supply elasticity. First, the sign is negative, which means the income effect dominates, and the dominance of this income effect is often used to explain that there is a decline in the hours of work during the survey period. So, this decline in the hours of work can be attributed to the income effects associated with rising in real wages. So, because of that we are having a negative sign and the income effect dominates. Second, the labor supply is inelastic, it is less than 1, which means hours of work for men do not seem to be very responsive to the changes in the wages. And the third one is that this is a consensus estimate on the labor supply elasticity for prime age men. There are enough evidence which suggests that the labor supply elasticity probably differs widely across men, women, between younger and older workers. So, why there is so much of variation in the estimates of labor supply elasticity across the studies? If you look at it, it seems that much of the empirical research in this area is flawed by number of statistical and measurement problems. If you look at the equation in which we are trying to derive the labor supply elasticity, the variables that are crucial for estimating this labor supply elasticity in the model are the person's hours of work, the wage rate, and the non-labor income. So, each variable bring together the difficult problems into the estimation procedure. Let us discuss one by one this, how these three variables they were estimated, they are measured, how we define those variables. So, first let us talk about the person's hours of work. What precisely do we mean by hours of work when we estimate a labor supply model? Is it hours of work per day? Is it hours of work per week or per year? The theoretical model that we have considered, it doesn't tell us what should be the span of the time period for hours of work to be measured. So the responsiveness of hours of work to wage depends on whether we look at a day, a week or a year. The longer the time period over which we are measuring this hours of work variable, the supply curve becomes more elastic. The shorter the time period, the supply curve becomes more inelastic. So, labor supply is almost completely inelastic if we consider the hours of work per week, but it is a bit of more responsive if we consider the hours of work per year. As discussed, it has been found in the literature that the labor supply elasticity is around minus 0.1, is based on the studies that consider the variation in the annual hours of work. So, they have taken into consideration the hours of work per year. So, there is a substantial measurement error in the hours of work measure. So, workers who are paid per hour, their wage rate is per hour. They know quite well how many hours they are working, and they know that what is the take home pay that depends directly on the length of their hours of work. But many of us, however, are paid annual salaries. We make very little effort to track exactly how many hours we work in a given week. So, when we are asked how many hours we work per week, many of us will respond that it's 40 hours because it's just an easy answer. So, actual hours of work, however, may have little to do with this mythical 40 hours work week for many salaried workers. Now, let us come to the second variable, which is the wage rate. How we are measuring the wage rate, how we are defining the wage rate. The typical salaried worker is paid an annual salary regardless how many hours he puts into her job. It's normal to define the wage rate of salaried worker in terms of average wage. The average wage is nothing but the ratio of annual earnings to the annual hours worked. So, this calculation tends to a measurement error in the reported measure of hours to work and the wage rate. Let me explain how it's a measurement error. Suppose that a worker over a period of time, he over reports his hours of work because of the way the wage is constructed, which is the ratio of annual earnings to the annual hours of work. Here the denominator is too large and we estimate an artificial low wage rate. So, high reported hours of work are then associated with low wage rates. So, as a result, we are generating a spurious negative correlation between hours of work and the average wages. Suppose instead of over reporting, the worker under reports his hours of work. So, the constructed wage rate is then artificially high, again generating a spurious negative correlation between hours of work and the wage rate. So, as a result, the measurement error tends to exaggerate the importance of this income effect. In fact, there is evidence that correcting for the measurement errors in the hours of work, it reduces the magnitude of the income effect. Sometimes, even in the absence of this measurement error, there is an important conceptual problem in defining the wage rate as the ratio of annual earning to the hours of work for salaried workers. The correct price of leisure in this neoclassical model of labor leisure choice is that the marginal wage. Marginal wage is nothing but the increase in the earnings associated with additional hours of work. So, the relevant marginal wage for the salaried workers may have little to do with this average wage earned per hour. So, therefore, there is some conceptual problem in defining the wage rate. Finally, when a researcher is trying to estimate the labor supply model, mostly encounters the serious problems that wage rate is not observed for the people who are not working. However, a person who is out of the labor market doesn't have a zero wage rate. All that we really know is that the person is having the wage below his reservation wage. So, many empirical studies to avoid the problem of calculating the wage of non-workers by simply throwing the non-workers out of the sample that is used for the calculating the labor supply elasticity. If you are doing that, then this procedure is fundamentally flawed. The decision of whether to work depends on a comparison of market wage and reservation wages. So, the persons who do not work, they have either very little wages or very high reservation wages. So, the sample of workers or the non-workers therefore is not a random sample of this population, because most of the econometric techniques and the statistical tests that have been developed specifically assume that the sample under analysis is a random sample. So, these techniques cannot be used to analyze the labor supply behavior of a sample that only includes the workers. So, as a result, the estimated labor supply elasticity are not calculated correctly. So, this problem typically refers to a problem called selection bias, how we are selecting our samples. Now, let us talk about the third variable in the model, how we define and how we conceptualize it. It is the non-labor income. How we estimate this non-labor income, how it affects the estimated values of this labor supply elasticity. Non-labor income measures that part of workers' income stream that has nothing to do with how many hours he works. For most people, however, the current level of non-labor income partly represents the return to the past saving and investment. Suppose that some workers have a preference for work. So, the shape of their indifference curve is such that they work long hours and they have high labor earnings, and they were able to save and invest a large fraction of their income in the past. If this is so, then these are precisely the workers who will have high level of non-labor income today. So, if a worker's taste preference for the work does not change over time, then these are also the workers who will tend to work more hours today. So, the correlation between non-labor income and the hours of work will then be positive, simply because the person who have large level of non-labor income are the person who tend to work many hours. In fact, some studies in the literature, they reported that workers who have more non-labor income work more hours. This finding would suggest either the leisure is an inferior good or that the biases introduced by the correlation between tastes for work and the non-labor income are suffering, they are sufficiently strong to change the sign of this estimated income effect. However, more careful studies that account for the correlation between taste for work and the non-labor income find that increase in non-labor income do tends to reduce the hours of work. So, these are the flaws or the problems while estimating the labor supply elasticity. That is why we get variation in the labor supply elasticity. How we measure these variables, the wage rate, the hours of work and the non-labor income. So, in the next lecture, we will discuss about the labor supply and we will discuss about the policy applications, the welfare programs, how these welfare programs affect the work incentives of the individuals, how they alter the decision of hours of work in the labor market, which finally decides the labor supply. Thank you.